Welcome to our introductory video on solutions. In this video, we are going to start off by looking at how matter is organized and classified. We're going to describe some common properties of solutions, and we're going to look at how we represent solutions visually using particle diagrams. Let's start off by looking at the classification of matter to locate what we've been talking about so far and where we're going. Now, matter can be classified based upon the particles which make up that substance. Matter is said to be pure if at the particle level there's only one type of particle. At the most basic level, this particle could be atoms. Now, those atoms can chemically combine to form chemical compounds or molecules, and those two different types of matter, atoms and compounds, are the types of pure matter because the individual particles are of one type. That's what we've been talking about so far. In this unit, we are going to move over to the mixtures. Mixtures are substances which consist of two or more types of particles. Mixtures can be classified based upon what they look like. If we see multiple phases, think oil and water, those are called heterogeneous mixtures. Mixtures which appear to only have one phase, so think tap water, are referred to as homogeneous mixtures. Now, homogeneous mixtures are also known as dispersions, and that's the term that I'm going to be used to refer to those types of mixtures. So this is a key new term, that dispersions are homogeneous mixtures. And dispersions are composed of particles which are dispersed in some sort of medium. We'll talk about some of those examples later on. Other than this introductory lesson today, we are going to be talking about one type of dispersion, which are called solutions. Solutions are a specific type of dispersion in which the dispersed particles are very small. They're very smaller than 2 nanometers. And so these are particles which are atoms, ions, or small molecules. So we're talking about very, very small dispersed particles, things that we've been talking about in chemistry so far this year. Now, even more specifically, we are generally going to be talking about aqueous solutions, which, as you know, are homogeneous mixtures which has water as the medium. So aqueous solutions are dispersions which have very small particles dispersed in water. Let's now go and look at different types of dispersions in more detail. To review, dispersions are homogeneous mixtures. Dispersions are classified based upon the size of the dispersed particle. We're going to go through those different classifications from large dispersed particles to small dispersed particles. At the larger end, we have suspensions. Suspensions are where we have very large dispersed particles, greater than 1,000 nanometers. In terms of the properties of suspensions, they are typically opaque or translucent because they scatter light. This is because the particles which make up the solutions are so large. Suspensions can be separated by physical means, using a centrifuge or through filtering. And the best example that you probably can relate to is human blood, or I guess any type of blood, where we have cells, which are the dispersed particles in the medium. So when we're thinking about the size of suspensions and the dispersed particles, we're thinking about the cellular level or larger. Moving down to a smaller range of dispersed particles, we have colloids. Now, here are where the dispersed particles range, but they're typically between 2 and 1,000 nanometers, which really means we're talking about large macromolecules. So the types of molecules that you discuss in biology often, carbohydrates, fats, and so on. These could also be things like viruses and other very small biomolecules. Colloids range in properties depending on the size of the dispersed particles and sometimes can be filtered. Some good examples are basically any sort of dairy product in which uh, you have carbohydrates, you have proteins, you have fats dispersed in water. And depending on the size of those dispersed particles, they can be more or less opaque. Aerosols are often colloids as well, in which you have large biomolecules or viruses, which are the dispersed particle within a medium. As was mentioned in the classification of matter chart, solutions are the type of dispersions in which we have very small particles, less than 2 nanometers. Rather than thinking of a number, just think we're talking about atoms, ions, small molecules, just this type of things that we've been talking about in chemistry. Even though solutions may have a color, they do not scatter light, and so they're typically transparent. And most importantly, for our purposes, is they cannot be physically separated. Okay, you can't filter out a solution. In order to separate the solute from the solvent in a solution, we have to do it chemically through chemical reactions. And that's going to be a large part of this unit, is figuring out how we do that. We have specific terms for solutions in which the dispersed particle is called the solute, and the medium in which the particle is dispersed is called the solvent. And remember from the classification of matter chart that if that solvent is water, we call it an aqueous solution. Let's consider some particle diagrams for some solutions here, because it's helpful to visualize these, because the difficulty with solutions is that they look like pure matter. If you look at tap water and pure water on a macroscopic level, they look the same. If we were to zoom in at the particle level for pure water, we would see only one type of particle. Now, each of those particles have an internal composition, H2O, so there's 2 hydrogens and 1 oxygen, but the particle itself, they're all the same. Same with glucose. Glucose consists of carbons, oxygens, and hydrogens as well, but the individual particles are all the same. So we have 2 pure substances. If we dissolved the glucose in water to get a glucose solution, we'd have these large dissolved particles, the solute, which is glucose, dispersed in a sea of water molecules. So more than one type of particle. Now, even though we think, okay, those glucose molecules are quite large, on the scale of things, those molecules are still quite small. In fact, a glucose solution is still transparent because of the size of the glucose molecule. One final example of a type of solution which we're not going to be studying, but is a very common type of solution that we encounter every day, are alloys. Alloys are metal-metal solutions. A pure metal consists of one type of atom, where an alloy consists of one metal, which is the medium. In the example here, it looks like that would be gold. And then we have one or more other types of metals which are dispersed throughout. And the importance of alloys is that an alloy can enhance certain physical or chemical properties of that metal. So in the example here we have on the screen, pure gold is very, very soft. And also very expensive. And so an alloy of gold might make it a little more resilient to wear and tear for creating jewelry. It might make it a little bit harder and easier to manufacture as well. And so this is very common with metals, is that if we want to enhance one of their properties, an alloy is a great way of doing that by mixing metals together.